recommendation comes up, and that is how you deliver your applications. And our standard pattern for that would be to have a set of charts. We have typically called it the mono chart, but we acknowledge that you might have more than one of these. But it's kind of defining your deployment interface to Kubernetes. So you're not saying that any app can be deployed in any way to Kubernetes. You're saying we have a few patterns that we support, and if you don't fit into one of these patterns, well, let's talk about it first before implementing it. So if we were lined up to that point, then you'll see maybe where I'm going, is that when you implement that mono chart, I think that it should come out of the box with supporting the most common types of monitors for that application. Health check time, health check responsiveness, overall API responsiveness, any sort of crash looping or CPU notifications, CPU alerts, and you can nail it's the 80-20 thing. You can probably nail 80% of the monitors you need for your apps with 20% of the effort, and standardize that in that mono chart.
Yeah, this is how I have it done. Like,
okay, perfect.
Like standard labels. So, you will just like label different deployments and different like stateful sets based on their how critical they are. And I have like a set of standard Prometheus rules that will do lots of joins, really lots of joins, to filter different labels and send to the right Slack channel or the right notification channel. The rest is the 20%. The 20% left is the really custom metrics, like not like a pod crashing, like metrics based on the application metrics itself, like the Prometheus metrics that the application emits.
Can you describe a little bit more though? How are you using those joins and deciding the Slack channels? And are you doing that entirely within Prometheus? Okay.
Yeah, this is a complex port. So in the kube state metrics exporter, you have a metric called kube pod label, which has nothing but all the labels on the pod, or the labels that you whitelist. And then like I can do like so if I am trying to find a pod is crashing, not only like I do a query for the crashing pods, like I do a query for the crashing pod and join it with all the labels, join it with the specific labels, and I have a label for like how critical the service is, and the label for the Slack channel. And when I join these together, I get like a metric for pods that is crashing, that exists, that belongs to this specific label, like the Kubernetes, like app.kubernetes.io label, plus how critical it is, plus its Slack channel. And then I send all these labels to Alert Manager, and it will do the routing.
Okay. Yeah. Now, when you describe it that way, that seems pretty similar to our recommended approach. Obviously, we're using different tools. We're using Datadog and opsgenie. But our pattern is similar. We've standardized on a set of tags that must, or labels that must be present. So tags, if we're talking like AWS resources, labels, if we're talking Kubernetes, the tags we've standard on are team that owns the service, the name of the service, and the app that it's a part of. And then what we escalate on specifically are only things that are P1s or P2s. So what's interesting about this is that the service or the alert is what determines that it's a P1 or P2. You don't put that logic anywhere else. And then what you do is for your, in your case, I guess, Alert Manager, the escalation piece is all it knows what to do is, hey, I see a P1, I know what to do. I send it to this channel.
Yeah, exactly.
I see it. Yeah, exactly. And it creates those layers and makes it much easier to kind of get the pieces to fit together.
Yeah, and it fits like 80% of the needed alerts.
And then you know what I would do about the power users, the extreme use case is I would just present an escape hatch that allows a raw custom resource to be bundled together with that deployment, and that makes everyone happy.
Yeah.